Is there a data sheet then? No. No, nothing. No formulas. The only formula that they might give you is like if they ask you for the volume of a cone, they might give the volume of a cone formula in the actual question. Like they put the volume of a cone in the question. So you don't have to memorize those. That's the only thing. So the first thing we're doing today is product rule. What does product mean? Multiplication. So product rule is multiplication of two things. Now we need to know our rules really well. So we're going to need to be able to do product rule really well. We're going to need to know how to do quotient rule really well. And then chain rule really well. And then sometimes product rule is embedded in chain. And sometimes chain is embedded in product. So that's why we need to know them really well. So when they're put together, you can do it. Okay. So product rule is when two functions are multiplied. So we could say like an f and a g. So if I write f and g like that side by side, they are multiplied, correct? I don't need to actually have a symbol in there. So when you have two things multiplied, people won't spot product rule right away, and they'll just do the derivative of both of them side by side and be like, poof, I'm done. But that's not actually what you do. How you do a derivative of two things multiplied, this means derivative of two things multiplied, is you go f g prime plus g f prime. So what does that mean? It means I take not the derivative of one times by the derivative of the other, plus not the derivative of the other times the derivative of the other one. So basically you have to take not derivative, right? Plus not derivative of each. Now this is how it will always be shown. It'll be shown as f g prime plus g f prime. How I write it out is I actually switch them because it's commutative and because there's a plus sign in between. I can actually swap these, correct? So I can go g f prime plus f g prime. Now some people will say, well, why do you do that? Because that's the top of the quotient rule. The quotient rule is this with a subtraction sign in between. So I just write the product rule like this. So I memorize it like this. So when I get the quotient rule, I just have to put a minus sign in and a g squared on the bottom. It'll always show it this way. But if I switch these because of the plus sign, it doesn't change anything. So I always switch it. And I write it as g f prime plus f g prime. And then quotient rule is just a minus sign in between, if you do it the second way. Okay? Okay, let's look at an example. We're going to look at a really easy one. F of x equals 3x squared e to the x. Can you see how you maybe won't spot that as a product rule?
Yes.
But it's two separate things, right? So when I see this, I will immediately go so that I spot it as a product rule. Because the only way it isn't a product rule is if it's like just a polynomial, like 4x cubed, right? If I went 4x cubed times x squared, I could put those together and make it 4x to the 5 and then do the derivative of it. That I can do. But I can't put these together. They're not like terms. That's how they're going to sit. Okay? So the first thing I do, if it's me, and I'm doing this, I say, okay, this is f, this is g. Does it matter if I swap to them? No, it doesn't for product rule. It does for quotient because one's in the numerator, one's in the denominator. Then off to the side, I write out my derivative. So I go f prime equals, what's the derivative of f prime? 6 x.
X, just x. Just
X.
ignore mine.
So the 2 drops to the 3, makes it a 6, x to the 1. And what's g prime?
Yes.
It'd be e to the x. Technically, ln to the base, e, and the derivative of the exponent, which is 1. So that's why e to the x is just e to the x, right? Because ln e becomes a 1, and the derivative of x is 1, which is a 1. So it just becomes e to the x.
Well, why wouldn't you drop the x?
It's not the rule. It's the rule we just did with these. When you have a numerical base to a variable exponent, you can't use power rule. You have to use chain rule. You rewrite the whole thing. Ln of the base, derivative of the exponent. Not the exponent, derivative of the exponent.
Okay. Yeah.
So we're not bringing that x down. Yeah. Okay, so let's do product rule for this one then. So a whole bunch of people will tell me this is 6x e to the x. That's what I get on a test all the time. 6x e to the x. Wrong, but they'll give me 6x e to the x because they just do the derivative of both and call it a day. Okay? So you have to spot product rules. So I'm going to go f prime of x equals g. Thanks, board, for not joining in. What's g? E to the x. Then f prime. What's f prime? 6x. Plus f, which is 3x squared, times e to the x. And you could just leave it like this. The catch is, whenever you have an e to the x in your product rule, they'll always do an extra step and GCF the e to the x out. Now some people will say, well, why would the GCF the e to the x out? How do they know they're going to always do that? Because when you take the derivative of e to the x, you always rewrite it. Correct? So you're always going to share that e to the whatever it is in both terms, because whether it's just the f or the f prime, you're going to have, if it's e to the 3x squared, you're going to have e to the 3x squared in its derivative, and then ln e 6x, right? But you're always going to have that e in both of them. So when you have an e, always remember you can GCF out. So we're going to get e to the x. What else could we also take out?
X.
An x. And a 3. I'm going to write this in not this fashion. So it would be 3x e to the x is how they'll write it. 3x e to the x, and then what's left over? This one is a 2, plus sign, and what's left over here? X. Now some people will say, what if I don't do that? Because that's what I always get. You're in massive trouble next unit. That's what's going to happen. So we always practice taking out GCFs because taking out GCFs gets us our critical numbers for drawing graphs next unit. So if you don't take out GCFs now, you might be like, but what if I don't? It's still the same thing. Cool. Next unit, you're in big trouble because you won't be able to get any critical numbers. Yeah.
How are we taking out a 3?
The 6 and the 3 both give me a 3.
But the e's?
We take the e's out. They're gone. Then out of these two, what can we take out? We can take a 3 and an x. So they're in front. So you're taking the e's out. They're gone. What can I take out of these two? And a
3.
yeah. So the 3 and the x come out of these two. The e to the x come out of those two. This is one term, and then a plus sign one term. So what can you take out of common out of both of them? This is like two things multiplied.
Yes.
So these two things multiplied, I can take an e to the x out. I take my e to the x out, I put it in front. It's sitting here now, right? Those are gone. Then I say, in the other two brackets, what can I take out?
Oh.
You know what I'm saying?
Yeah.
Because this is one term, one term. Every single time product rule, you get two terms. What can you take out? Two terms. It always looks like it's almost like there's 4 because there's brackets. There's not 4, right? There's two terms, two terms. Okay?
And we can still take a GCS out if they're adding together?
As long as you take a GCF out of this one and this one, because there's two terms. It has to come out of both terms. Yep. Okay. Here's an example for you to try. That one out. So, this is my F, this is my G. So I'm going to go, F prime is what? Yeah, we drop the 2 down, 6x to the 1, so just 6x. Plus 2, very true. G prime, if you use a chain rule, because it's a base to a variable exponent. Numerical base to variable exponent. Most people are really good with the e's, and then I give like a 4, and you're like, I don't know how to do this. Like, it's the same thing. E or a 4 or a 7 or a negative 22. But negative 22 is not going to work. You're on the negative, and it's going to be a problem. But nonetheless, 22. Okay? So, we rewrite it. E to the 4x cubed. Then we ln e, which gets us a 1, and I'm showing it every time. Now some people are like, I don't need to. Guys, remember, I don't do anything just because I want to waste my marker, because my marker isn't a real marker, so I'm not like wasting it. I'm not going to get a new one. Like I do stuff because I know that it'll stop you guys from making stupid errors, okay? So the reason why I write ln e is not because it becomes a 1 and I'm just like literally doing extra work. It's because the moment I switch it to anything but an e, a 4 or a pi or a 22, like I was saying, you're going to have ln of that, correct? And if you're someone who keeps skipping the ln e part, guess what you're going to skip when it's a 4 or a pi or a 22? You're going to forget to go ln of that. And you're going to get the question mark. Okay? So whenever I have a numerical base to a variable x1, I write ln of the base and it becomes a 1 and I don't care. Because then when I get 4s and pi's and stuff, I'm not going to make a mistake. Okay? Then what follows behind?
12x squared.
12x squared, the derivative of the exponent. Exactly. Okay. So then we go back here and we go f prime of x. And we go g, which is e to the 4x cubed. F prime, which is x plus 2. Yeah. Now if you want to, you can actually like take the 2 out back there and make it 2 bracket 3x plus 1 and take the GCF out first if it's easier for you. You can do it. Plus, then we do f 3x squared plus 2x, and then g prime e to the 4x cubed times 12x squared. Now we're trying to take a GCF out of here and a GCF out of here. Now sometimes you can take GCFs out, sometimes you can't. Remember that if an f or a g is an e to the x or something like that, or a 4 to the x or whatever, you will always be able to take a GCF of it out, because our first step in the derivative is to rewrite it. So it will be in both the g and the g prime. All right, what can I take out of both of these?
E to 4x cubed.
E to the 4x cubed. Okay, so that would get rid of both of these. Is there anything I can take out of the other ones? Yep.
Yeah, it's the 2.
I can take out a 2.
But there's 3x squared. You can multiply.
I can take a 2 out of this one. I can take a 2 out of the 12, and I can take a 2 out of both of these. It has to come out of a bracket. That's why I put the brackets. The whole thing has to come out of one of the brackets in terms. So if I look here at this one, and I look here at this one, I say, okay, I can take out that bracket. Then in the leftover brackets, the 6x plus 2, the 3x squared plus 2x, or the 12x squared, is there something I can take out of this bracket and take out of either of these brackets? And I can take a 2 out of this one, right, which would make it be 3x plus 1. And I can take a 2 out of this bracket and make it be a 6. It has to come out of one of the brackets, not all of the brackets. Okay? It's 1 for 1. So if I can take something out of one of these brackets that I can take out of one of these brackets, I can take it out. So I can take out a 2. So I can also take out a 2. And then I write what's left over. So if I take an e to the 4x out of this one, it's gone. If I take a 2 out of this one, what am I left with?
3x plus 1.
3x plus 1. What's in between these? A plus sign. So did I really need the brackets?
Yes.
No. And then I take an e to the 4x cubed out, so that's gone in the second bracket. And then I take a 2 out, which comes out of the 12x squared. So this whole bracket stays the exact same. I can't do anything to it, right? So I'm going to get 3x squared plus 2x. And then out of the 12x squared, I can take a 2. So what am I left with? 6x squared. And I'm not done. You will always, the square brackets after you take a GCF out, you'll always distribute and collect like terms. Every single time. And you're not done until you do that. So I'm going to write the 2 first, because I always put the e to the x after. So 2e to the 4x cubed. And then these are going to be round brackets in your textbook. I make them square so that I know that that's what's left over after I take my GCF out. So 3x plus 1, does it need brackets? Is there a number in front of the 3x plus 1? No, so we can drop the brackets on that. Can we just drop the brackets on everything after the plus sign? No, we have to distribute first. So we're going to get 3x squared times 6x squared, which is 18x to the 4, because we add exponents and we have like bases. 2x times 6x squared is 12x cubed. Now, they'll probably rearrange those in 18x4 plus 12x cubed plus 3x plus 1, but that's not wrong. and I'm lazy, so I'm going to go like this. But they can rearrange any pluses, yeah.
Do you ever want us to subtract division and factor it down, or just leave it like that?
So in the next unit,
Okay,
if it could factor, right?
for the moment, just leave it expanding.
Right. Yeah. All right, here's an example for you. You try this one. Export. F of V equals 5V squared minus V plus 1, and then V cubed minus 1. Find F prime of V. V is just not X. It's the same thing. They have to use different variables because you guys get really stuck. It doesn't actually make a difference, but okay, do the questions. You have to remember that you have to GCF as well, because sometimes it'll ask you to find the second derivative and the third derivative. And the only way you can find the second and third derivative is if you have your two things. Like so here, now if we wanted to find the second derivative of the previous example, this would be this 2e to the 4x cubed would be our new f of x, and this would be our new g. Right? So that's why you have to do the GCF thing so that you can find the second derivative as well. All right, let's look at this one. So we have f, we have g. Could we have just expanded these because they're polynomials? Could we have just distributed them and then done power rule? Yes, get the same answer. Okay, so here is f prime. What's f prime? 10 v minus 1. And what's g prime? 3v squared. So we get f prime of v equals g, which is v cubed minus 1, times f prime, which is 10v minus 1, plus g, which is, f, which is 5v squared minus v plus 1, times g prime, which is 3v squared. Okay, is there anything I can take out of them? So I look here, and I look here, and I say, is there anything I can take out of v cubed minus 1? No. 10v minus 1? No. So then I'm immediately done. So I can't take anything out of those two, right? But am I done? No. No, I have to do what first? To expand and then collect like terms. So we're going to get, which is why you'd get the same answer if you expanded first and then did power rule, right? If you expanded first and did power rule, we're going to get the same as if we do product rule and then distribute them back together. The catch is that only works for expanding and then power rule if these are both polynomials, right? If it's an E, you're just going to cause yourself a whole bunch of product rules embedded in like an equation. Not good. All right. So we're going to get 10v to the 4 minus v cubed minus 10v plus 1 and plus 15v to the 4 minus 3v cubed plus 3v squared. Then we have to collect like terms. So we get 10v to the 4 plus 15v to the 4 is 25v to the 4. Minus v cubed minus 3v cubed is minus 4v cubed. Minus 10v, no such thing. So we have a plus 3v squared minus 10v plus 1. Okay, so I'm going to write down the AP questions first. So this is in section 2.4. So I'm giving you forewarning. I was going to take it in on your test, but then I forgot to. Tomorrow, at the very beginning of class, I'm checking your homework from chapter 1, like physically walking around and looking at it. So please don't have it in 70 different places. That will not be a productive way to get through it quickly. and I'm going to get through it quickly. So I might just give you a not done your homework if it's going to take 20 minutes. Okay? So please just get all your homework together in one spot, and then I will come around and check everyone's as you go along, and I'm going to give you like little questions you can do on your board. I don't really care, but I'm going to check your homework, okay, while you guys do your board questions. All right? So please, tomorrow, have all of your homework in one place. If you're flipping through 70 different spots with 80 different tabs in your book, at least if you can flip to the tabs quickly, I'll take that, okay? Because some people have it throughout their homework, and that's fine, but then put little sticky tabs on the side so I can see them. Okay? Makes sense? Tomorrow, checking your chapter 1 homework. So this is section 2.4. The AP problems you're going to have to do so far are one, two, three, 4, 7, 8. And then the actual problems you're going to have to do are 15, 16, 17, 18. I don't know why I didn't just say 15 to 18, but whatever. And then I want you to do, now the catch with 45 and 48, they want you to do the first and second derivative. So these have f prime and x double prime.
Do you know how to do that?
Yeah. This is why you're not teaching. You're not at your prime today, Dreidel. So
I am so.
so the reason why we take the GCF out is so that when you have a new F and a new G, so we can do product throw for F double prime. Yes. Yes.
So could you just,
Friends, for this one you can only do 4 today.
I'm gonna say 18.
The other ones you can do tomorrow.
And what?